Okay, guys, now we're going to come back and we're going to look at the justification for why the change of base formula is allowed. So the question posed during class, which is a great question. Something that we should, I should have maybe started with actually, but like I said, I think it's nice to kind of get some practice and see it in action before we see why it's true. So just to remind us, this is what we're trying to prove. This is the change of base formula. Again, with the stipulations before, I think I should even say A and B are greater than 0. They're not equal to 1, and M is greater than 0. Otherwise, I'll get some undefined, either I get some undefined expressions or else I'll get some impossible to solve expressions. All right, so what we're trying to prove is that the log base of A of M is equal to any general log I choose over any general log I choose, top number over bottom number, M over A. But what I like to do instead of using a general choice, I'm just going to show that I can do it for ln in particular. Because I like ln's. Ln's are on your calculator. Ln is the most important log in math, arguably. Okay, so then let's prove this thing. So what I do is I want to start with one side, show it's equal to the other side, right? Let me start with this log then, log base A of M. And let's just give this a name. We'll call this x. That's equal to x. What I want to show is that x is equal to this then, right? Or well, I'm going to focus on the right side, the ln one. So I want to show x is equal to that guy. First thing I'm going to do is unpack this by definition. What this means by definition, remember, is that a to the right side is equal to that m. So in other words, a to the x is equal to m, right? That's the definition of a log. Now all I'm going to do at this point in the strategy is just to solve for this x, solve for this x value. So remember, x is the thing that we started with, right? Now to solve, what I'm going to do is I'm going to just take ln on both sides. So take an ln of here and an ln of this guy. Now what that does is when I take an ln of a to the x, I can apply now my rules of exponents, logarithms with exponents. Remember the exponential rule for logarithm says if I've got an exponent like this, I can pull it out to the front as a multiplier. So what I end up with is x times ln of a, and then this side is just ln of m, right? So x times ln of a is equal to ln of m. Now I want to solve for x. To solve for x, I just divide both sides by ln of a. So x is equal to, let's change colors here to distinguish lines. X is just equal to ln of m on the top over ln of a in the bottom. And oh, look, that's what I was after, right? Now I could replace ln if I wanted to. Instead of using ln here, I could have just as well done log base b, and this would have been log base b of m or log base b of a, the same idea. We just proved technically we proved this red one, but really it's the same proof as this one if I just replace ln with log base b. And so there, that's the end of the proof. This is just a justification for why we can apply the change of base formula that we've been using. Okay, that's it.